Okay, so yeah, this paper palette talks about serverless computing, talks about serverless functions, and talks about load balancing inside those serverless computing platforms. So at the very kind of high level, the functions, the serverless functions, they work in the following way, like as shown in this picture here. So there are multiple maybe users, multiple like instances of user application, like on this side, and they will do multiple invocations of some function, and each of the invocation goes to the serverless platform, okay, right here, and the serverless system runs the function and eventually returns the result to the user. And inside this serverless platform, we have the load balancer, whose job is to map the invocations to the actual workers that have the function code and can run that function. And they also mentioned like scale controller. Like in practice, those serverless platforms are quite complicated, right? So we need to be able to like create new workers, remove workers, yeah, deploy the functions to the nodes and so on and so forth. So this load balancer is not like as a primitive load balancer, but it kind of should know where hopefully there are already like instances of that function deployed on which worker, so they can direct the traffic accordingly. But the big idea of the serverless function, serverless compute, is like those invocations, they're very independent from each other, right? So the serverless function is stateless. Like as soon as the function terminates, that state is lost, right? So the next invocation doesn't really know about anything that has been done in any previous invocations of the same function. So like if there is any state, it needs to be kind of preserved externally in some like outside storage system, a database, or blob storage or something like that. So this makes the job of the load balancer easier, because when the invocation comes in, it just needs to find the proper home, the proper worker that can run that particular function. But this is also like where the problem lies, according to this paper. That's not really how people like to run the software, and not really how people like to use the serverless, right? So it happens to be the case, according to the authors, that like many applications, when running in this serverless environment, they have to redo the same kind of work many times, right? So one invocation may need to maybe gather some state from outside storage, and then serve that state up to the user. And then the next invocation may do exactly the same. It may need to like retrieve the same state, do something to it, and serve it up to the user. So a lot of the times, there would be benefit of having that state cached somewhere, right? So and this is what Palette is trying to do. So they introduce that they add caching into the serverless. Like the function itself can cache some stuff. But if the function caches, let's say we have like a worker here that cached something, the green cache or whatnot, then whatever the invocation that needs green stuff needs to go to that load balancer, and the load balancer needs to know to direct it to the worker with the appropriate cache, right? Otherwise, we have a cache miss, and we kind of degrade down to like the base case where we need to retrieve that state from the storage and do everything from the beginning, right? So yeah, that's kind of the idea of the paper. They introduced that cache, and they changed the load balancer to essentially have a more sticky mapping between invocations that will likely need to have that cache and the functions. So they actually have a picture that describes their system right here. So the system is called Palette, and they they say that the functions have colors, right? So you know, a function can have like a green color, and then this coloring policy will know it's a green function. It will assign that color, and when things go to the load balancer, in this case they call palette load balancer. This load balancer will know that okay, this particular function, green function, will need to go to a green worker, right? Similarly, if we have like a function that will, an invocation that has red color, it will go to the load balancer, and load balancer will, direct it to the red worker. So yeah, like very trivial idea. Obviously, in practice, those are not colors; those are just some keys and values, right? So maybe the green function is, or green invocation, or maybe any invocation that, for example, tries to retrieve the same post from a social media website is going to be assigned the same color, right? If that happens, then we can cache that post, that cache the content, add the worker, right? So it can be cached at the worker, and then by the virtue of this assigning the color based on what information we really need to cache, and going through this load balancer, we can route the proper functions, hopefully to the proper workers that have that stuff in cache, and avoid paying the price of going to storage as well. So yeah, they talk about like some implementation details, right? So mainly the important part are what is that like coloring policy, right? And they suggest using consistent hashing. So your color is really just some key that you use to determine the bucket, essentially, right? So every invocation that has the same key, or maybe the key is the post ID or something like that, right? Will get the same color, which means it will likely go to the same worker if that worker is available. But they also have other suggestions like bucket hashing, and I believe the one that they use, another one that they use in the paper, is a color table, which is just remembering the map of which worker has what keys assigned to it, or what colors assigned to it. So yeah, I think this is probably the level of detail that I want to cover in my improv here. But I do want to look a little bit at the at the evaluation. Yeah, let's see. So yeah, like for example, figure 9 talks about TPC-H benchmark. Oblivious means no palette caching. And yeah, so they compare their serverless against the server full environment, in this case, Dask. Yeah, what happens is, palette, because of the caching, can achieve, in many cases, similar performance to, a server full environment, versus like no caching, or, caching without the cache-aware load balancer, tends to have worse performance. I guess that's what the paper was trying to accomplish. So bingo, and yeah, we're done. Okay.